From now until the expected start time, we're just going to get cruising. So good evening. My name is Emily Weber. I am a machine learning specialist, solutions architect at Amazon Web Services. What the heck does that mean? I ask myself the same question. The reality is that I spend most of my time working with customers. I work directly with customers across every stage of their cloud journey. We're talking very small companies, very large companies, all of the spectrum here. I feel like my actual skills kind of fall somewhere in between architect plus data scientist plus research scientist. There's so many interesting ideas in this space that it's really fun to stay up to date. I spend a lot of time working with customers who are new to machine learning, particularly folks who are quite technical, especially folks who are familiar with AWS, but maybe quite new to the machine learning space. And so when I'm working with my customers, I always like to actually ask a pretty broad question. And the broad question I like to ask is, well, what the heck is a computer, right? I think a lot of the times we take this question for granted, right? Particularly in today's world, where many of us, wake up in the morning and we start looking on our phones, then we continue looking on our laptops, and we leave looking at our phones. And so it's actually an interesting question. From my standpoint, if you look back at computational history, right? So the first person who proposed what a computer could be, right, was Charles Babbage. So that was back in the 1800s. And that was Babbage's picture, right? He called it an analytical engine. And the goal of the analytical engine was to solve any arbitrary problem. And so you formulate your problem on the right-hand side, and then you shoot it down the center, and it will break out all the subcomponents and figure out the answer to this problem. One of the first people who criticized this idea said, hey, that sounds useful, but it won't be able to do anything new. That was actually Ada Lovelace, right? And so Ada Lovelace is known as being the first programmer on our planet. But more than anything, she was a thinker, she was an intellectual, she was a scientist. And so she's reading through Babbage's proposal. She says, wow, that sounds really useful. But again, it won't have a life of its own. It won't have any creativity and a sense of originality. That became known as the Ada Lovelace critique. When you look at Alan Turing's work, what's interesting is you find that he was actually obsessed with artificial intelligence, right? Turing was convinced that it was possible to not just design a computer to perform general intelligence, but that computer could be so intelligent that it would mislead another person, and that person would think the machine was actually a person and not a machine. And so that's what the Turing test actually refers to. When you speak with folks who are based in London and the UK about artificial intelligence, frequently they actually start with Turing. Margaret Hamilton was the first director of software engineering on the planet because she invented the term software engineering. Software engineering was actually invented by women, right? And this was from Margaret Hamilton. If you're not familiar with this picture, this is Hamilton standing next to the suite of code that she herself wrote to land Apollo on the moon. Prior to Admiral Grace Hopper, which is this picture down here, computers literally just did math. Right? That was the extent of what a computer could do, was arithmetic. And so everyone told Grace Hopper that was all a computer could do. And so Grace Hopper says to herself, in order to productionize this technology, what I actually need to do is develop a way for people to write something in a language that makes sense to them and then translate it in a way that computers can read. And today we call those compilers. Katherine Johnson became especially famous recently in the film Hidden Figures. And so she was back in the early day when a computer was a woman who did the math for the men, right? That really happened. Computers were women who performed arithmetic for the scientists who were men. And so Katherine Johnson was actually necessary to launch multiple spacecrafts because she was the best. And so she kicked some serious butt. And then Carlos Guestrin has been a key figure in helping XGBoost come to life. Outside of the NLP world, a vast majority of customers are still performing classification, right? By and large, classification tends to be the first way to solve many a machine learning problem. And so XGBoost is still a very common algorithm. And so I bring these up for a number of reasons. And there we go. Personally, I have two theses, if you will. The first thesis is that I just think that since computers have been around, People have always wanted computers to be intelligent, and they've always wanted computers to have their own sense of agency. And so what I think we're seeing today is less about this is a new fad that's going to go down, and it's more about this is actually where computing has always gone. And personally, anyone who knows me knows that I'm a very firm believer in diversity and inclusion. I have a number of projects that are directly related to that, and so I'll be walking you through those. So in terms of AWS for AI ML, there are actually just 3 things that we really want to hit. And the first one is called S3. So hands up if you've worked with S3. All right, beautiful, we're cruising. So S3, EC2, and customers, right? So Amazon starts with customers and we work backwards from there. I cannot tell you how many SageMaker workshops, or SageMaker workshops primarily, I've been involved in where I get through and here's what SageMaker does, and then people stand up the room and say, oh, but I actually need a model repository, or I need batch transform, or I need XYZ. And then what happens is that actually gets incorporated into our product roadmap. 90 to 95% of our roadmap comes directly from customer requests. So don't be shy, don't hold back, tell us what you want to see, and then as I like to say, wait until Christmas comes, and then we'll see what happens at the end of the year. So in terms of machine learning, AWS is really interested in helping make machine learning easier than it has been. Machine learning is historically very difficult, challenging, reserved for the elite few. And what we want to actually do is open up access to this. So to literally put machine learning in the hands of every developer and data scientist. And that leads us to what we call the machine learning stack. Well, we really want to understand here that there's actually a very clear philosophy guiding how Amazon thinks about its services, in particular around AI/ML, and it comes in these 3 different flavors. And so, essentially, these are stacks in a technology stack, right? These are layers in a technology stack. At the lowest level, if PowerPoint is working with me, okay. So at the lowest level of the stack, we have what I call customer managed services. And essentially, these are pieces of infrastructure that you as the customer can manage the end-to-end life cycle of this. This can be an EC2 instance. These can be outposts if you're trying to run on local content. This can be wavelength if you're trying to put together a 5G solution. This can be a local zone if you're trying to deploy something that's actually near a metro area. So there's a lot of innovation that's happening at the lower level of the AWS stack. I'd encourage you to check out some of the reInvent keynotes that happened in December to take a look at that. I spend most of my time one level above that. And so I call that AWS managed because AWS is managing the infrastructure. We're turning on the EC2 instances, you use them, and then we're turning them off. We're pip installing all the packages. We've got lots of software. We've got lots of features built out for you. So you don't have to write as much code. There's literally less work required because we're doing what we call that undifferentiated heavy lifting. We're actually building out all of those basic steps that you as customers do on a day-to-day basis, and then we're adding that to the service so you can move faster. But then the highest level of the stack is what I call fully managed, and these are fully trained machine learning models that you can leverage. So as a developer, you can hit recognition like an API and get a classification response for the content in that image. Or you can use comprehend to automatically extract sentiment, keywords. You can actually build a recommendation system using personalized in your own data. You can build a forecasting system. You can leverage Code Guru to analyze the code in your commits and make sure you're using your cloud resources cost effectively. Huge amount of innovation that's going on at the top of the stack. And so what we actually need to do is pick the solution that works the best for us. And so there's overlap here, and that's okay. Because sometimes you'll start at the top tier of the stack, right? Because maybe you realize that you can actually use personalized to build your own recommender, but then you realize that you want to add another component. And so you'll drop down to SageMaker. But if you have really extensive simulation software you want to run, you might just spin up another EC2 instance. There is a tremendous amount of action in terms of machine learning on AWS. And the reason why this matters to you is that in the event there is a single customer up here who has a workload that is similar to yours in the slightest degree, the odds are they've spoken with us about it, and the odds are they've actually given us feedback about what they want to see, and we're acting on that feedback. And so what that means is that you get access to all of the innovation and feedback that we get with our customers basically for free, which is pretty cool. If you didn't know this, my slides are not working. There we go. If you didn't know this, the NFL uses Amazon SageMaker. Right? If folks were watching the Super Bowl that happened here, so the NFL uses Amazon SageMaker for next-gen stats. The way this works, so football players are outfitted with IoT sensors. Helmets, shoulder pads, cleats, the ball, and as they're running down the field, we can capture all of that IoT and telemetry data. You can combine that with the 22 cameras that are around the field and then label it with the commentators. Actually, so you can label it with where folks have run on the field and then perform route predictions. So you can actually take a picture of the field and draw a line on the screen for where the receiver is going to run prior to the play even starting. And so this is in use currently. So cool stuff. So undifferentiated machine learning lifecycle here. This is what happens. You build your models, we need to train them, but then we need to deploy them. And so when I work with teams, most customers have something in play for build and train. It might not be the most efficient use of their time, and it might not be giving them the most value they can get, but they're able to get it done. It's a little bit more rare to come across a team who has a really slick solution for that last step. And so Amazon SageMaker is a tool that was designed to meet each stage of this workflow. So let's break this down. So step one on Amazon SageMaker is a managed EC2 instance. And so Alex did a great job of calling out resizing the notebook instance. So that means you can start running your models and writing your, analyzing your data on a smaller EC2 instance, and then you can just resize it when you actually need something larger. There are 17 built-in algorithms in SageMaker, so if you want to just use a built-in image classifier, you absolutely can. You do not need to, and we're going to cover the other examples here, especially because we want to bring our own PyTorch models. There is what we call a machine learning training service, which is to say when you fit your model, we're going to turn on a new EC2 instance. We're going to copy your model onto that instance. We're going to get your data out of S3 and onto that cluster. That cluster is going to be up for the number of seconds your model is training. The second your model finishes training, that cluster comes back down and you can go on your merry way. We have a managed hyperparameter tuning service. This is using Bayesian optimization, and so you can leverage SageMaker to automatically find the best hyperparameters, again with our Bayesian optimizer. There is a hosting service. So after you have your model defined and trained, with a single line of code, you can automatically create a RESTful API around your model. We're going to cover some examples of how to do that, but literally you just get your model and then you say model.deploy. We're going to create that web server for you. Some folks need it on a batch schedule, so if you have a time-based solution you are solving for, batch transform is a great option. We've got a bunch of SDKs and a lot of content out there. And so to hit this home, there are actually 5 ways you can train a model on SageMaker. Right, and so number one is the built-in algorithm. And when I'm working with teams, usually that's the one we start with because the infrastructure is slightly different. And at least for folks in Chicago, usually it takes a little bit of time for us to really get comfortable and proficient on the new platform. So we'll start with the built-in algorithms. But I definitely encourage folks to grow their skills and move into a place where they can write their own models, such as in PyTorch. And so script mode and Docker container are 2 ways that you can write PyTorch models on SageMaker. The Docker container means you're literally bringing a Docker file, you're copying your code into that Docker file, you're building your Docker container, pushing it to ECR, and then dropping it onto the SageMaker cluster. Script mode is a lot easier. Script mode is where you can literally just bring a script, drop it into our PyTorch estimator, as we learned about last session, and then run that on a training job and deploy it. The AWS Marketplace has over 250 models that you can actually just use. Last fall, I did a demo at Strata on a solution we called mansplaining. It's an Alexa, yeah, time to laugh. And so it's an Alexa skill where you can be recording your meeting, such as with Skype or Chime, but you record your conference bridge. When you're finished, you get your MP3 or MP4 file, right? You drop that thing in my S3 bucket, drop it through my pipeline. I'm going to use transcribe to figure out when everyone is speaking. And then I'm going to get the timestamps and use transcoder to get these tiny, tiny byte files. I can hit a model from the marketplace that does audio gender classification, write back the analytics, drop that in a DynamoDB table, which hits my Alexa skill, and then I can say, Alexa, analyze my meeting, and she'll say men were speaking for 90% of the time in this meeting, even though they were 25% of the participants. So, fun stuff.
Are sales teams using that?
Are any sales teams? No, sales teams are not using that. Yeah. No, but I'm looking for customers on that solution, so if you're interested, let me know.
How do you get data from Alexa? Isn't that private data you're not supposed to get?
No, so this solution starts with a recording. So
How do you get the recording from Alexa?
No, the recording comes from you.
Yeah.
You record it like in Chime, and then Chime or your web conferencing bridge creates an audio file.
Oh, so you're recording what the thing is saying, Alexa, and your conversation?
Alexa is only receiving and then playing back the audio.
Maybe we can talk after.
Okay, yeah. It's a one-way though, it's not a two-way.
You can record it on your phone.
You can record it anywhere, yeah.
And
You upload
It takes an
Yes.
MP3 file. It takes an audio file. Yeah. Question in the back.
Do you also have model performance monitoring?
Yes.
Please repeat the question.
Yes. So the question was, do you have model performance monitoring? The answer is overwhelmingly yes. We're about to get to that. So I am talking about SageMaker Classic right now, and I'm going to talk about the Classic infrastructure so we can really understand that. Then we're going to flip a switch and look at the reInvent launches from 2020 and see that it's actually doubled, which is really exciting. So the most common place that machine learning is developed is on a laptop. There are clear upsides to developing on your laptop. Obviously, this is very flexible, right? You can do whatever you want to. This is very personal, and it's very easy to get started. My friends, there are downsides to developing on your laptop. The number one being that obviously you can't scale. As soon as you want to, if you want to train your own BERT model, you can't do that on a laptop, I'm sorry to say. Or if you want to fine-tune a BERT model on a data set that is larger than will fit in the RAM of your computer, it's going to break your computer, right? We've battle tested that. We know that that one is true. And so obviously you can't scale it. You can't run an application in production off your laptop. As soon as you close your laptop, your app is toast, right? That's a sad fact of life. And then the last step, in our space, there is so much innovation, right? There are these new solutions that just come out. Obviously, PyTorch has all these awesome things that we want to play with. But in order to get our hands on those things, or across any of the other open source packages that are out there, the first thing we actually need to do is upgrade pip, upgrade virtual environments, create a virtual environment, pip install all of the solutions into that virtual environment, and try and make sure that all of my software dependencies in that virtual environment are compatible with anything else that I need, so I'm not breaking my machine. And if you're a person like me, that's actually really challenging. And that's going to take me a solid 4 to 6 hours to do on a good day, if it even works. And so what I'm happy to say is that on SageMaker, you literally don't need to do that. You just turn on a new machine. The other place that machine learning is commonly developed is on servers, right? And we sometimes feel really, really familiar with servers, right? For lots of folks, this feels very familiar. But there are actually some clear downsides to developing on servers. I'm not going to go too deep into this, but this is a core value proposition for why cloud is helpful, which is to say, teams are usually stuck in this path of over or underutilizing servers, right? Let's say you're an innovative company and you just had a really successful hiring season, and so you have a whole new fleet of data scientists, which is great. But in your data center, you only literally have 2 servers. And so if you have 12 data scientists, are you going to have each 6 of those people hitting your 2 servers? that's actually going to break your servers, right? Because they're going to be overutilized. Those nodes are going to go down. And so then you say, okay, well, here's what I'm going to do. I'm going to order more servers. And it turns out it's actually going to take me about 6 months to get that order through procurement, to get those servers actually shipped to my place, rack and stack, provision and configure them. Meanwhile, my data science team is sitting there doing nothing, right? And so that's underutilization. And so this is why companies are moving to the cloud, because you can elastically blend your compute to your needs. And so the key point that I really want you to understand is that SageMaker gives you dedicated compute for every stage of your flow. So you get dedicated notebooks, dedicated training jobs, and dedicated endpoints on top of a lot more. These are your notebook instances. Literally, we're talking about an EC2 instance. Your EC2 instance has an EBS volume already attached. You can actually drop a GPU on there, so you can just attach what's called an elastic inference. It's a portion of a GPU. Attach it to your EC2 instance, a whole bunch of things. We're going to cruise here. It is very common to clean your environment with a Lambda function. So you can leverage Lambda to basically turn off your notebook instances and make sure they're not being utilized. Common flow on a training job. You're on your notebook instance, and you call model.fit. Once you fit your model, we're going to shoot your data out to S3. We're going to turn on new EC2 instances. Those EC2 instances are dedicated to you and your model. No one in the world has SSH access onto those machines, right? They are managed by Amazon, and that is that. You have the Elastic Container Registry. That is hosting your algorithm. If you are putting your PyTorch code in a Docker container and then registering it, it's going to live there. Otherwise, you're going to avoid it and use the script mode, which we're going to talk about. But in any case, your image is downloaded to that EC2 instance or to that fleet of EC2 instances. We ran a benchmark test last summer on 9 terabytes of data in a single XGBoost model across 45 machines, and it trained in 95 minutes. So you can really scale up, or scale out rather. And then we're going to write your trained model back to S3. So you get that model artifact after your training job is finished. And again, the whole process comes down.
Did you SSH to the?
No. To the training job, no. No, that's fully managed. A really good thing to know about is that you can decrease your costs by up to 90% by using SageMaker Spot. So we talked about this. SageMaker Spot is a great way to, again, just save on your costs or your training on Spot instances. Again, just to hit this home, automatically create a RESTful API around your model. We're going to go really fast here because we're already a little bit over. It is very common to actually develop a multi-account strategy. So under no circumstances do I want to see a company run their entire business in a single AWS account. That just turns into a nightmare multiple years down the road. What you actually want to do is develop a multi-account strategy. So over there on the left-hand side is where your resources are running in prod. You've got a prod EC2 instance. If you're responding to millions of requests an hour, which apparently isn't that much traffic, say my friends in caching and in microservices. So if you're responding to millions of requests an hour, you can actually cache those in like Redis to get model responses faster. Redis responds in less than a millisecond. SageMaker, the endpoints are going to respond in a few milliseconds, so single-digit milliseconds. But again, Redis is going to be even faster than that. Drop an account next to that and use this kind of buffer account to promote new models, so to push new models into production, and then demote your logs, obfuscate your production data, drop that back in your data science account, where you can set up a dashboard and have your teams actually analyze the result of your model that's running in production. So exciting stuff. It is very common to also leverage batch transform. So batch transform just starts with cron job. You're going to hit Lambda. That's going to hit S3, and then SageMaker, yada, yada, yada. So that's based on, again, a time of day. All right. We're going to very quickly here walk through all the new features, and then we're going to jump into PyTorch, and then we're going to call it a day. So let's get through this. So SageMaker Studio is now in general preview in Ohio. So SageMaker Studio is a fully integrated IDE. We wanted a solution that would feel very, very natural to developers, and that would give us all the productivity boosts that we heard from the field over the last couple of years was really helpful. So SageMaker Studio. Experiments. You can use SageMaker to manage your experiments. When you have projects and you want to see how well your team is performing and what activities were done, you can use SageMaker experiments. Processing jobs. If you just want to turn on an EC2 instance, analyze a bunch of data, and turn that off, processing is for you. We have a debugger, so you can run a training job and then actually debug what that training job is doing, why your gradients are vanishing, and then keep cruising. Autopilot is a solution here. Autopilot will look at your data, run feature engineering based on just general stats, figure out your prediction problem in some cases, and then train your model. Kubernetes, operators, model monitoring, multi-model endpoints, and augmented intelligence. And now we're going to bring it all home here with PyTorch and SageMaker. So number one, your general rule of thumb here, if it fits in Docker, it's going to fit in SageMaker. So just really, let's internalize that. Anything you can do in Docker, generally speaking, you can do in SageMaker. So that means you can copy your code into this Docker container, specify your script. However, you don't need to touch Docker if you don't want to. And so that is why we have what's called script mode. And so script mode generally means that I have a script. My script is sitting right here, maybe in my local directory, and I'm going to pass that in to what's called this PyTorch estimator. And so the PyTorch estimator is just using the PyTorch container. So it's using the AWS managed PyTorch container that we have that I'm actually about to show you, and then you can just run your script using our container. So you can use our container, and you can actually extend that container. So let's say you want to import sort of our container as your base in a much smaller Docker file, and then extend it by just running your code in that container. You can actually do that. Number 4, you do not need to write your own web server. You can absolutely train a PyTorch model however you want. You don't even have to train it on SageMaker if you really don't want to, but you can still deploy it. So number 1, you're going to use this SDK, right? So you're using our SageMaker SDK to reference a pre-trained model. That model is sitting in S3. You've got your SageMaker role and the script, right? And the actual, the PyTorch script. Then, again, one line of code, predictor.deploy, model.deploy rather. Model.deploy, number of EC2 instances, and the type. So you can default to having 2 EC2 instances plus an elastic load balancer. That's an ALB because it's at the application level. So again, you're going to use this when you don't want to manage your own API. Number 5, yeah, question.
What kind of server does it create in?
So it varies based on the framework and the source you're using. Most of our Python examples are using Flask.
Does it use some kind of microservice architecture?
It's using the SageMaker service. And then it lets you build a microservice architecture. Number 5, you do not need to scale your training jobs yourself. So here is an example using our reinforcement learning estimator. We have loads of reinforcement learning examples, should that be of interest. And you can specify a Python script right here, number of training instances, and you can really just increase that. We were learning earlier about different ways you can distribute your model and your data. And so that definitely holds true on SageMaker. There's a lot of variety there. And I'm about to show you some of those. And so this is one way of, in your training script, setting the number of your hosts and then basically looking at a global level. I'm sure there's a better way of doing it, but that's one way of getting it done. So some learning resources here for you. At risk of being self-promotional, there's actually a reasonably nice YouTube video series. So I have 11 videos that you can watch. I think we just hit 33,000 views, so I guess there's some market adoption there. But 11 videos. I go very, very deep on all those components. You can pick, fast forward, rewind, whatever it is you want to do. So that's if you like consuming via content or via videos. We have 250 example notebooks that you can just use right off the bat. So this GitHub repository is probably the single best place. You can use this to evaluate all sorts of capabilities. All of our new features have their own set of example notebooks. So you can walk through those to gain some familiarity. And with that, thank you very much. Definitely feel free to reach out on LinkedIn. I love staying in touch with folks. And I hope you had a good time.
We'll have a few minutes for questions.
Yeah. OK. Any questions? Yes, in the back.
The training pipeline, do you have a service for that, or is that something we can do?
Yeah, so we have a feature of SageMaker called Inference Pipeline that lets you connect up to 5 containers. And then in your 5 containers, you can just operate those in serial. So just one right after the other. You can have up to 5. On top of that, again, if it fits in Docker, it fits in SageMaker. So anything you want to write in that image is up to you. Yeah, in the back corner.
How about pricing of the notebook instances? Is it exorbitant as in the very early days, or has it kind of leveled up to what EC2 instances are? Or?
Yeah. So there is a small upcharge, but if you look at the entire life cycle of the amount of engineering that's required to accomplish the same set of features on your own, then it's a clear one-way bet there. We also have
I'm asking specifically for the notebook instances, not for the training part, but for the
Yeah. So the pricing varies all the time. So it's possible that there was an update recently. But I know you had a question earlier about can we just do it for free? And so there is nothing stopping you from creating AWS accounts that just run on the free tier. I do this myself, actually. I just create a bunch of AWS accounts, like literally just keyed off of my email. And those are just, so every AWS account that you create has a free tier. That free tier is based on the length of that account, that's based on the compute resources that you're using, so you want to monitor it closely. But again, there's nothing stopping you from just creating as many of those as you need to.
Do you recommend any tools for monitoring performance of models, like weights and balances or biases or anything like that?
Yeah. So I mentioned earlier, let me cruise over there. So one of our many reInvent updates is called model monitoring. And so model monitoring is right down here. And this is going to monitor an endpoint that is running in production. And it's going to let us monitor the level of the statistical data that is hitting that endpoint. And so for all of the features in your data set, you can actually set a baseline for what you want the stats on that data set to be. And then if the nature of that market actually changes over a period of time, you can detect that via model monitoring. And we're intending to improve that over time. Yeah.
Like, if you can give me an example of a typical use case, like what services a typical customer uses, all the services you showed Amazon, and what would be their bill in a month, and how does that compare with Azure and Google?
Yeah. So essentially, we actually see that it's really helpful when. So essentially, AWS is very committed to lowering our cost of operating. Over the past multiple years that AWS has been in operation, we've actually lowered our price many times. That is because every single team has goals around lowering their costs of operating so that we can pass those costs directly back to the customer. I don't want to go into too much more details there now, but essentially, we work really hard to lower costs across all of our customers. Yes.
Does SageMaker providing tools for model interpretation?
Yes, so that is another very interesting area. I know we absolutely have some folks who are taking a look at that, but I also think there's an opportunity around some of the solutions in PyTorch, and specifically how they could be connected, I'm just hypothesizing here, with augmented intelligence. because what augmented intelligence does is it leverages our managed data labeling solution, which I didn't go into detail here. It's called Ground Truth. And Ground Truth lets you take a bunch of data and then specify how you need that labeled, whether that's image, text, just numerical data. Augmented intelligence lets you run a model in production. When the confidence level off of that model is below a threshold that you can set, then that's actually going to trigger a manual review. So that's going to trigger a person who's actually going to review that model prediction and then can reclassify that data. And so I think it'd be really awesome if we integrated a PyTorch solution there, and so that after a model is running in production, you could potentially see not just the data, but also the weights and or the gradients to see exactly what was most informative so that the person can then correctly relabel. Fun times. We have a conference coming up, Remars, if you didn't know about this. This is a new conference that Amazon is doing that's going to be coming up in June here in Las Vegas. It's fun because all the lots of leaders from Amazon will come in and talk about how they're using machine learning across their business. We don't really have time for this, but let me just show you a couple slides while we're still here. Last year, we shared some information publicly for the first time about Amazon Go. Yeah, so this is Go. So essentially, what's going on here, so this was shared publicly for the first time at Remars last year. So over on the left-hand side, we see the raw video feed of people who are in stores, right? People who are actually in the Go stores. Over here, all the way on the right-hand side, we see what appears to be a binary semantic segmentation, or pixel mapping, right? So that's a binary prediction problem where we're actually extracting the people from the background. Then you see the next in what I call like a logical decomposition. Then we see this number 3, which is a multi-class problem, right? Clearly we're seeing heads, shoulders, arms, hands, and then we see step number 4. And this fourth component here is a stick figure representation, right? So what's interesting is that, again, because there's this logical decomposition that's happening, that pixel, that stick figure representation is actually much easier to classify. The last piece I want to show you, again, just because we're here, is, and so this is a drone from our Primera solution that was also announced at Remars last year. And this drone was produced in part by a machine learning model. So I see a lot of interest in using machine learning to help improve product design, actually, because for many companies, particularly when you've been in business for multiple years, you have a lot of data about products that you've tried and products that have worked versus not worked. And so you can imagine just building a simple binary classifier, right, to automatically compare a new product or a new design against the database of historical designs that you have, and then automatically giving your teams feedback about how well their proposed product is predicted to perform relative to your historical ones. So definitely exciting stuff there. All right, I think we are solidly out of time. Thank you for sticking through to the end. Appreciate your attention.